So one of the things you may have noticed when you were doing the homework for 11.6 is that graphing quadratics, it's a lot easier when things are in what we call the graphing format as opposed to in the normal simplified multiplied out form. So a very natural question to want to ask is there a way to convert something that's currently in standard form and rewrite it so that it's in the graphing form? Maybe this will be a better choice. Maybe you can rewrite the equation and then take the easy path from there. And there are other reasons, it turns out, why this graphing format is actually useful. It's useful not just for graphing. There's a lot of reasons why we might want to convert from one form to the other. So if at first you're realizing maybe it's not worth it, the fact is that there are plenty of situations where it is going to be worth it. So the bad news is that although there is a technique to do this, the technique is completing the square. And if that means you kind of don't want to convert into that other form, I totally understand. Completing the square is not a lot of fun. And if you wanted to graph this thing, leaving it in multiplied out form is very tempting. It's not that much harder to use the vertex shortcut instead of the HK thing. And once you know what A is and making a table of values, none of that seems like it's such a price to pay. And completing the square doesn't seem like it's worth it. But the thing is, converting it into that other form has plenty of other uses that are going to come back to haunt us in another chapter we're going to run into later in this class. So even if you don't think you're going to use it for graphing, you should still learn what we're going to be learning today. Okay, so using completing the square to convert this really can be done two different ways. And some students like working it one way. Some students like working it the other way. And it's not a clear majority where one of these techniques is much more popular than the other. It's like 60-40. It's almost 50-50. About 60% of people like technique number one and about 40% like technique number two. So I'm going to teach both techniques. You don't have to learn both techniques. Just look at both of them. If one of them seems better, feels more instinctive, learn that technique. And then when you're doing tests, you can just use the technique that you like better. But I'm going to teach both of them. And I'm going to, of course, do the same problem and show you that no matter which technique you use, you get to the same answer either way. So, first of all, if you're using technique number one, you have to set up for completing the square a little differently than normal. Instead of moving the 2 to the other side of the equation, what you do is you move it just to the side, like actually physically more distant on the piece of paper you're using. And with the 1/2, you can't divide by it to the other side of the equation. Instead, what you do is you take the coefficient, the -1/2 here in this case, and you factor it out of these first two terms. So if you factor it out from x squared, you get x squared. And here's one of the things that's sort of a downside to technique number one. Be careful about what you get here. In fact, it's probably easier to think of distributing the -1/2 back in. And what does it have to be to make sure you end up with a +3? Well, it's going to have to be a -6. -1/2 times -6 is going to give you +3. That's how you make sure you get your factoring right. And then the completing the square happens here. We want to have parentheses squared from this. And just like with normal completing the square, we say, okay, there's a -6 there, so when I'm done factoring it, it's going to be a -3. And then in order to end up with a -3 there, I really need to have a +9. That's not really quite legal. Just like with completing the square, you really can't just do one +9 and everything's cool. What we usually have to do with completing the square is add 9 on both sides of the equation. But things are so different here, that's not what we're going to do. We are going to correct for that adding 9 a different way. We're going to sort of maintain balance through a different technique. And the first time you see this, this totally feels like cheating. Like you can't possibly be allowed to do that. But it actually is totally mathematically legal. If you want to be able to add a 9 like this, but you want to sort of balance it out, you can also balance it out by immediately also subtracting 9. Because you effectively just added 0 in the middle of an equation, which doesn't change anything. And the first 3 of these 4 parts factors into this, and that extra little minus 9 is still kind of lurking around there. I know, totally weird idea. Feels like cheating, but it's actually completely legal. You can add and subtract anything you want in the middle or at the end or at the beginning of an equation, and then take the 2 pieces you just put in there and go different directions with them. So the plus 9 gets to be part of the factoring, and the minus 9 is just sort of residue left over. And then to finish this up, we've got to take that negative 1/2 and distribute it back in. So we end up with f of x equals negative 1/2 times the x minus 3 squared. Negative 1/2 times negative 9 makes positive 9/2. And we're not completely done because there's still that minus 2 that we have to combine with the plus 9. But that's really just a matter of getting a common denominator and adding and subtracting fractions like you've been doing ever since elementary school. So get a common denominator. That'll be 4 over 2. 9 over 2 minus 4 over 2. You're going to get 5 over 2. That's what technique number 1 looks like. And some people like it. It's kind of faster. It's got fewer steps. But some people don't like it. They really don't like that plus 9 minus 9 and the factoring out the coefficient thing and the shifting the 2 to the sideways business. So let me also show you technique number 2. You might like it better. I mean, there's no guarantee. You might not like it better, but it's worth a shot. What we do with technique number 2 is we sort of more closely follow normal completing the square steps. And what I mean by that is normally what you would do with the minus 2 at the end is you would add 2 to the other side of the equation. Well, that's what we do in technique number 2. We add 2 on the other side of the equation. And the thing that's weird about this is you have never before ever dealt with f of x like this. You've never touched that side of the equation. It's always felt sort of like off limits, like you're not allowed to go there. But you're actually totally allowed to go there. You can move things to that side of the equation as long as when you're done you have f of x by itself, you're okay. The other thing that we would do here is we would get rid of this coefficient by multiplying or dividing. In this case, I'm going to get a little fancy. I'm going to multiply both sides by minus 2. Only because that's a lot easier to write and a lot easier to think about than the alternative. The alternative would be, quote, divide by negative 1/2. Dividing by negative 1/2 sounds like a real pain, but it's equivalent to multiplying by the reciprocal of negative 1/2. So multiplying by negative 2 will work out a lot easier here. So that will make this into just regular x squared. And it'll make this into negative 6x. That seems kind of familiar, doesn't it? Negative 6x? Yeah, it does seem kind of familiar. That's because these two techniques are equivalent. I mean, what we're doing should come out with the same answer, so partway through, if you see similar things, you shouldn't really be too surprised. And then we do regular completing the square, just like you would normally do. Cut this part in half, square it, and add that on both sides of the equation. So there's none of this add and subtract 9 stuff. It's regular add 9 on both sides of the equation like you've done in the past. So the advantage to technique number 2 here, that people who prefer it, they prefer it because of this, is the completing the square stuff is working like completing the square normally works. One of the downsides is we're not done at this point. We've got to get f of x by itself. So I'm going to have to subtract that 5 to the other side. And I'm going to have to divide by negative 2, which will give us negative 1/2 x minus 3 squared, and negative divided by negative will give us positive 5 over 2. Notice, It's the same answer. We get the same answer either way, so both of these techniques will do the job you want to do. You're going to pick which technique works with your brain better. If you look at one of these and it makes more sense than the other, don't try to force the other one to work. Stick with the one that makes sense to you. That's the smart way to approach this topic. And this is pretty much the only thing we're learning in 11.7, which might seem like it's not very much, but that's because it turns out that this process of getting things into this form, this is more important than you think it is. So please take it seriously. Learn how to do this, because you're going to need it in a later section of the book.